Hello there. Welcome to SSC Science Tutorials. Today we're going to discuss the topic force and motion. Now, to understand force and motion, we have to first understand the concept of speed. Now, speed, as you know, is the measure of how fast an object is. Its formal definition would be how quickly it could cover ground. So its definition would be the distance traveled by the object that you are measuring over the time it took to do so. So, what are the units of speed? Well, you can deduce that from knowing what is the units for distance. Well, it could be cm, centimeters, or it could be meters or kilometers. And for time, it could be seconds, minutes, or even hours. So as you can see, this is a division, right? So distance over time. So you can deduce here is that its units would be also the units of its distance over its time. So it'd be cm over second, which is cm per second, meter per minute, kilometers per hour, or any combination of these units. So the usual unit that we use, which we call the SI unit, which is the standard units that we usually use in science, would be meters per second. This is as it is the most convenient and also most frequent use of speed, as most objects in our daily life travel at a speed of meter per second. So an example of such an movement would be perhaps a car or a runner. So let's use the runner as an example. So here's a person. If they were to travel this distance of 100 meters in a competition, if they were to do so in 10 seconds, then their speed would be 100 meters, as seen in this definition here. 100 meters is the distance and 10 seconds. So it'd be 100 divided by 10 would be 10. And then meters per second. So depending on your unit, if this were kilometers and this were hours, then it would be 10 kilometers per hours. But then again, usually we use this unit. So as you can see from this definition, it's the speed of an object very much is dependent on the distance that the object is traveling and the time that is traveling. So if the distance for a traveler, let's say again the same example of a runner trying to cover the distance of 100 meters, if there's another runner who covers this distance in 20 seconds, third runner in 10 seconds, and one in 5 seconds, then the speed of each of them would be 100 meters divided by 20 seconds, or 100 meters divided by 10, and 100 meters divided by 5 seconds, which would each equal to 5 meters per second, 10 meters per second, and 20 meters per second. As you can see, as this was our original speed, if it increases, if the time it took increases, so the time increased, the speed, as seen here, decreased. So speed decreases. So as time increased, speed decreased. If the time it took for them decreased, as you can see here, it took them 5 seconds as opposed to 10 seconds. So it decreased, its speed increased. So it's inversely proportional. But so that is the relationship between the time and speed. So let's have a look at the relationship between its distance. So again, you can see here, originally he travels 100 meters in 10 seconds. But if the distance increased to 200, while the time he took is the same. So he traveled 200 meters in 10 seconds. So you can see its speed would be 200 meters divided by 10 seconds. So it'd be 20 meters per second, an increase from the original 10 meters per second. Or if it's decreased into a 50 meter, so you traveled 50 meter per 10 seconds, then it would be 5 meters per second. And as you can see from this, if the distance increased while the time remains the same, speed also increased. If its distance decreased while the time remains the same, speed decreased. So it's directly proportional. To better describe the motion of an object, you could utilize a DT graph. So what does it mean by DT graph? So speed is dependent on distance and time, right? So you can denote that as D and T. So if you say there's a DT graph, so the graph would consist of the distance and time. So here's an example. This is a DT graph. So in first second, second second, third second, 1 meter, 2 meter, 3 meter. So let's say the person is traveling in 1 meter per second. So in 1 second, it travels 1 meter. So in 1 second, it travels 1 meter. So it'll be here after 1 second. And in 2 seconds, it travels 2 meters. So 2 seconds, 2 meters here. And then goes on 3 seconds, 3 meters. So you can see if we connect all dots, draw a graph, you can see there's a straight line. So you can see that this is a DT graph. This describes the motion of an object. So if you see a straight line like this, it means that it has a constant speed. Its speed is the same throughout. So it's at the 1 second mark, its speed is 1 meter per second. At its 2 second mark, it's 2 meters over 2 seconds, still 1 meter per second. So at any time, its speed is the same. But even in this scenario, there are two types of such graphs. As you remember, the speed is distance divided by time. So you find the speed of the object by finding how steep the graph is. So which is what we call slope, which is the y-axis divided by the x-axis, as this is the distance and this is the time, which is, well, equals to speed. And let's say if we have a graph that looks like this, you can see that here in the first graph, the slope is steeper, while in the second graph, the slope is gentle. So deducing from this, you can see that the speed in the second graph is actually lower as opposed to the first graph. You can see that maybe in the third second mark, it had traveled 3 meters. But in the third second mark of the second graph, it had only traveled 2 meters, sorry, which illustrates that this graph has a lower speed. Now, how about this graph? You can see from the 0 second mark to the second mark, you can see that it has again, a straight line with a slope. So it has constant speed. In this case, we call it is experiencing something called a uniform motion. As uniform means the same, so its motion is the same, it's moving at the same speed. But you can see from the second to the third second here, it's actually a horizontal line. So what does that mean? Well, if you look at the distance, at the second, it's at the 2 meter mark. But at the third second, it's still at the 2 meter mark. So it means that throughout that 1 second, its distance has not changed. So it would mean that it's traveled 0 meters over 1 second, which is equal to 0. So the speed over here is 0. Okay. But then what exactly happened between the second and the third second? So as you can see here, at the second second, it has traveled 2 meters. But in the third second, it also only has traveled 2 meters. So judging from this, you can tell that during this 1 second period, it actually has not moved a bit. So the distance it has traveled is 0 meters, and the 1 second has gone by, so which equals to 0. So the speed in this period is 0. So it's actually not moving. Now, we talked about a uniform motion, but then that would mean there's not a uniform motion. So uniform motion means that the speed is the same. So if its speed is not the same, like here, we have a draw graph, its speed could be like this. It's ever changing, it's always changing. In the first second, it has traveled half a meter. But in the second second, it had already traveled 1.25 meters. And in the third second, 3 meters. So you can see that the speed at each time mark is different. So its speed is changing. So in this case, the speed is not uniform. The motion of the object is not uniform. So it's a non-uniform motion. This graph over here is also a non-uniform motion, as its speed changed here. So now that you know about dt graphs, you can perhaps draw a dt graph by yourself. Let's say that at first a person running is in 10 meters per second, then at the 2 seconds later changed his speed to 1 meter per second, and 1 second later became 0 meter per second. So you would imagine how to solve this. So in 2 seconds, so you would imagine for the first 2 seconds, it will have traveled 10. For the first second, 10 meters. Not long enough. Okay. So for the first second, it will have traveled roughly 10 meters. So about here. And the second, the same, and another 10 meters. So 20 meters. Then in the third second, only 1 meter. And final second, nothing. So this would be how we draw a graph. You can determine the slope through the speeds and the time. How do you determine the distance it traveled through that time? So if you can remember, this is speed. So if you want to find what meter it is, you mean that you have to times the time it took. So seconds divided by each other. So this one times this, 2 times 10, 20 meters. Or 1 meter per second times 1 second, cross the seconds out, 1 meter. So you can figure this how to draw a dt graph using these. Oops, sorry, I missed out this. Now, if in exam or any assessment you miss out these, then that would be devastating. So remember to draw to label all your diagram, all your axes with the appropriate labels. Now, we've talked about what speed is. And speed is a type, but its motion is not always uniform. Now, sometimes its speed is not always the same. So as you can see here, the slope is like this, but here it's not moving anymore. So speed is not the same, but there's an idea of average speed. Now you probably know what average already means. So it's basically an approximation of the entire thing. So not every minute or every second, like as we've previously done, but the whole entire thing in total. So 3 meters over 3 seconds goes to 1 meters per second. So you can see that its average speed, despite probably in its first second, is about 2 meters per second, but its average speed, so total, not every instant, but its total, would be only 1 meter per second. Observing. Okay, fine. So 3 meters divided by 3 seconds is one, oh, for God's sake.